Hello good day viewers, let us find a solution to this calculus problem. We're asked to find the points on the curve where y equal to 2x cubed minus 3x squared minus 12x plus 20 is parallel to x-axis. Before we start, let me sketch something here. Suppose we have y and x-axis like this, and it happens we have a curve like this. You should know that this curve is only parallel to x-axis at the turning points. These are the turning points. And also you should know that at that turning point, the first derivative is always equal to 0. Therefore, we are going to differentiate this function, set it to be equal to 0, and find the critical points. So since we have y to be equal to 2x cubed minus 3x squared minus 12x plus 20, dy over dx, we are going to differentiate it term by term. This 3 will multiply 2, you have 6. X, you reduce the exponent by 1, it becomes 2. Minus 2 will multiply 3, we have 6. X, you reduce 1 from the exponent, you have 1, and you don't have to write it. Minus, naturally this has power of 1, you multiply by 12, you get 12. Then x raised to the power of, you reduce the power of 1, it becomes 0, and x to the power of 0 is 1, so you don't even have to attach x. And the derivative of constant is 0. So at dy on dx equal to 0, we are going to set the whole of this to be equal to 0. We have 6x squared minus 6x minus 12 to be equal to 0. All of these 3 terms contain a common factor of 6, so we can divide every single term by 6. Divide this by 6, divide this by 6. 6x squared divided by 6 will give us x squared only. Minus 6 divided by 6, we have only x here. Minus 2, this is equal to 0. Then this is a quadratic equation that can be factorized. Just think of 2 numbers you can multiply to get negative 2. But when you add them together, you get the coefficient of x here, which is negative 1. And the numbers are positive 1 and negative 2. So we have x plus 1, x minus 2. Once you take 1, you multiply by negative 2, you have this. And 1 minus 2 will give you minus 1. The whole of this equal to 0. Then by setting each factor to be equal to 0, we have these 2 factors equal to 0, which implies either x equal to negative 1 or x equal to positive 2, right? We are looking for the points, therefore we need a corresponding value of y. Then we take the original equation, which is y equal to 2x cubed minus 3x squared minus 12x plus 20, and substitute those 2 values of x to get the corresponding values of y. All right, here is the main equation. Let's substitute f of negative 1. This is equal to 2 multiplied by negative 1 to the 3rd power, minus 3 multiplied by negative 1 to the 2nd power, minus 12 times negative 1, then plus 20. Let's simplify this. Negative 1 to the 3rd power is still negative 1 times 2 is negative 2. Then negative 1 squared will give us positive 1 times negative 3 is negative 3. Negative negative is positive. We have 12 here positive. Then plus 20. Then this is equal to, the whole of this will give us negative 5. And negative 5 plus this will give us 7. And 7 plus 20 is 27, which means that f of negative 1 is equal to 27. Now let us substitute for f of positive 2. For f of positive 2, we have this to be equal to 2 multiplied by 2 to the 3rd power, minus 3, 2 to the 2nd power, minus 12 times 2, then plus 20. 2 to the 3rd power is 8. 8 times 2 is 16. Minus 2 to the 2nd power is 4. 4 times 3 is 12. Then minus 24. Then plus 20. 16 minus 12 is 4. Then 4 minus 24 will give us negative 20. And negative 20 plus 20 is 0. So this is equal to 0. So we have f of 2 to be equal to 0. So we conclude that the points we have when x equal to negative 1, y is equal to 27, negative 1, 27, and when x is 2, we have y to be equal to 0, and hence these are the points on the curve where the curve is parallel to the x-axis. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.